Now let's take that a step further. We've mentioned that we can have multi-dimensional lists or lists of lists. How do we iterate over those? So let's imagine that instead of just averaging one set of numbers like we did before, we're interested in averaging multiple sets, each set averaged within itself. For example, this could be a grade book. Each individual list could be a single student and their grades, and so we want to calculate each student's average. So in this case, the top level list would be a list of students, and each individual list would be a list of that student's grades. We want our result to be a list in the same order as this list of each student's average. So the first item in the list should be the average from that first list, and so on. Let's start by looking at the main program to see how we would actually get some data into there. Here on line 15, we're creating a variable called my2D_list. 2D for two-dimensional. It's a list of lists. To make things a little bit easier to read, I've put each sublist on its own line, and the extra bracket at the beginning of the first line and the end of the last line tells us where the overall list is. So in this way, I've created a two-dimensional list, or a list of lists. And now, down here on line 21, I want to run the function 2D_average on that 2D list of lists, and then print the result of that operation. So calling my2D_average sends execution up into our function, and my2D_list becomes in2D_list. The argument becomes the parameter for this function. So now in2D_list has the same value as my2D_list in our main code. We're initially going to create a list to hold our results, but initially it's empty because we don't yet have any results to put. Every time we get a new result, we're going to append it to this list of our results. Now what we're going to want to do to calculate these averages is run a nested loop, a loop inside of a loop. The outer loop is going to loop over each list in the overall 2D list. It iterates over each student. Each time it runs, numList is going to take the value of the next list from 2D list. So on the first iteration, it'll have that first list. On the second iteration, it'll have the second one, and so on. Then because we want to average within each list, we create sum inside of that for loop. That means we're going to create 5 different sums, but we want that because we want 5 different averages, one for each student. And then we're going to run our second for loop. Here we're going to iterate over numList. Now remember, numList was created by our outer loop, which means that one by one, numList will be each list from our 2D list. Now within each of those lists, we want to iterate over the numbers in that particular list, and one by one, add the number to our ongoing sum. Then when we're done, we want to divide the sum by the number of items in that particular list, and we want to append that to our list of results. We don't want to just return it right there, because then it would only calculate the average for one student. Remember, when we return, the function stops running. Instead, we don't want to return until we've gathered all the different results. That's also why our return statement is on the same level as our outer for loop. It means that our return statement won't run until the outer for loop is done running. Then when it is, that list takes the place of our function call, and so we print our averages, which as we can see over here is exactly what happens. Each item in the list corresponds to the average of one of the lists in our 2D list of lists. The first one, for example, would have an average of 90.4. This kind of nested loop structure is how we iterate over a two-dimensional list. Now we could take this further. We could have a list of lists of lists, or a list of lists of lists of lists, or so on. With a list of lists of lists, we would need 3 nested for loops to iterate over each individual value. And there's also one other interesting note here. Note that our result must be a list because we must be able to call append on it. But this exact function would actually work if this was a 2D list of tuples instead of a 2D list of lists, or even if it was a 2D tuple of tuples instead of a list of lists. Nothing in either of these for loops is reliant on our 2D list actually being a list instead of a tuple. That's another part of Python's flexibility. Whenever possible, it'll let you deal with things like lists and tuples in the same way, unless you're trying to do something that you can't do to a certain data type, like trying to append to a tuple.